Okay, so now we have already shown you how to find the missing side length of both a hypotenuse and a leg. So now we're going to move on to real world examples of using the Pythagorean theorem. So the first one we're looking at has a set of houses that are on the corners of a what makes a right triangle. So you'll notice that they have already told us that the A street equals 2 miles, if you'll notice right here. And the B street equals 1.5 miles. So it looks like between James' house and Sarah's house, there's also a road, and we're trying to figure out how long that road is. So if A and B hit each other at a perfect perpendicular or 90-degree angle, we can use the Pythagorean theorem to figure out how far James' house is away from Sarah's house. So let's go ahead and set this up. I'm going to start by writing the Pythagorean theorem, so it's easy for me to see where I need to substitute in my values. So first I'm going to take the length of street A, which is 2 miles. So I have 2 squared plus 1.5 squared. So that's the length of street B, and it's okay that it's a decimal. That's going to equal the length of the street between James' house and Sarah's house. So now if I go ahead and simplify, I have 2 squared, which is 4, plus 1.5 squared, which is 2.25. That has to equal C squared. And again, I knew that I was solving for C because it's the side that is opposite of my right angle, which means it's the hypotenuse, and we represent that with the letter C in our Pythagorean theorem. So 6.55 has to equal C squared. And remember, this is the hardest step to remember for students, is that in order to figure out what C equals, I need to get rid of that exponent by taking the square root of both sides. So when I do that, my exponent to the power of 2 and my square root cancel each other out, and I'm just left with my length of that side, which is the square root of 6.55, which is 2.6, about 2.6, and we should label this with our units, which is miles. Okay, so this next one. So this is real world. Talk about real world problems, right? So when you buy a TV or a monitor and it says like 48-inch, that's the diagonal of the TV. So if you look at this monitor where it says 27, that's the diagonal of this monitor, and that's how they measure them in the box. But what happens when you get home is that you need to make sure it fits. So I have a spot where I had to make sure the width of my TV, it's not very big cupboard. I had to make sure that like the 24 inches would fit. And then in this case, we don't know this other side, right? So when I look at this right away, I notice, hey, this is going to be my right angle, which means that 27 is my hypotenuse. So when I go to solve for the missing side using the Pythagorean theorem, I need to make sure that I'm plugging in the values that I'm given in the correct spot. So this 27 is the hypotenuse, so I need to make sure I put that in for C, right? I'm going to put it in red here. So that's 27 squared. And then 24 would be one of my 2 legs of my right triangle. It doesn't matter if I plug it in for A or B. We've talked about that a couple times. And then we don't know B. So now we're going to go ahead and simplify this. These are going to be some large numbers, so I'm going to use my calculator. 24 times 24 is 576, plus B squared equals 27 squared would be 729. Okay, so we've plugged in our values, we've simplified, so we've gotten rid of the exponents by multiplying, and now we're going to solve. So I'm going to draw my line. I need to get B all alone. I'm going to change colors again here. So I'm trying to get B by itself. So the first thing I need to do is subtract 576 from both sides. That's a 5. That should be a 576. So I'm left with 729 minus 576 equals 153. These cancel, so I have B squared equals 153. Okay, so we did a couple steps here. Last step, even students, even though I say this over and over, end up forgetting to do this last step. The last step here would be to take the square root of both sides. I'm left with b equals the square root of 153, which is about 12.4, and we should write inches for this one. Okay. Okay, so, I threw in this tough one. So this isn't a word problem necessarily, but this is a problem where we're using the Pythagorean theorem to find the distance between 2 points on a coordinate plane. And it looks scary, but it's really not, because to find the length of this line, all we're going to do is we're going to make our own right triangle. So I'm going to connect these, or I'm going to create a right triangle. So I'm going to go draw a line down from my first point and stop when I hit the x coordinate. That's the same. And then I'm going to draw a line here. And now I've created a right triangle. Okay. Now, in order to find the length of the red line, I can use the Pythagorean theorem. I'm going to go ahead and use my colors, right? So c squared represents the red line, or c does, right? This is c, and then this is a, and this is b. But in order to figure out how long those are, I just need to count. So I'm going to go ahead where my b is labeled. I have 1, 2, 3, that's 4. So I have 4 squared. And a I need to count to, which is 1, 2, 3, 4. And then I have 5, 6, 7, 8, 9, 10, 11, 12. So a equals 12. So I have 12 squared plus 4 squared equals c squared. So all I've done is I counted the value across that I made my right angle. I created 2 legs to create a right triangle. Now I can solve for the hypotenuse, which is the red line. So now I'm going to simplify. Oops, I wanted to use, hold on, I want to use blue to represent this side. So 12 times 12 is 144, plus 4 times 4 is 16. That has to equal c squared. 144 plus 16 is 160. And then my last step here would be to square root both sides. I'm left with the square root of 160, which is 12.6, roughly. So the red line up there has the length of 12.6 units. Okay, got a couple more here. So if I look at this problem again, there's no words to go with it, but it's a little bit different than the other problems that we've seen where we're just saying find the missing length. They've given us this rectangle, right? And we know that rectangles have right angles in the corner, which means the diagonal that's drawn here from P to R that I'm outlining in red, that is the hypotenuse because it doesn't touch the right angle of the side we're missing, right? So we're missing this side over here. Let's call it A because it's one of our legs. So we're going to go ahead and we're going to plug in all the information we know. We know that we're missing A, so we're going to leave that as A squared, and then B would be this 150 meters, and that's going to equal 170 meters squared. Okay, so now I'm just going to simplify. 150 times 150 equals, ooh, this one's getting big, okay, so 22,500. So I have A squared plus 22,500 equals, I need to do 170 times 170, which is 28,900. Luckily we get to use our calculator, so it's okay. And then my last, or I got 2 steps left. So the first step here is to get rid of this plus 22,500 by subtracting 22,500 from both sides. And I'm left with A squared equals 6,400 or 6,400. Then my last step would be to take the square root of both sides. And when I take the square root of 6,400, I'm left with A equals 80. So we should write A equals 80, and then our units on this is meters. Okay, I have one more for you sports lovers, right? So there's a picture of a baseball diamond. It says if a player throws throws the ball from second base to home, how far will the ball travel? Well, we need a little bit of information, right? If you remember from gym class or if you play baseball, this is home down here. This is first base, second base, and third base. So you'll see on the triangle below, but from home to second would be all the way here. So this happens like if a player is trying to steal second base, the catcher, oh, sorry, we're saying the second base to home. So maybe the second baseman has the ball and he has to throw it to the catcher because someone's trying to score a run. But in order to figure this out, we would have to know that the bases are 90 feet apart. That might not be true in middle school baseball, but it is true in high school and college and pro baseball. So from home to first is 90 feet. From first to second is 90 feet. So those are going to be our two legs, right? Because we should be able to tell right away that we're trying to find a hypotenuse because it is across from our right angle. So we have 90 squared plus 90 squared is going to equal our hypotenuse squared. Let's go ahead and solve this. So I have 90 squared is 8,100 plus 8,100 has to equal c squared. And 8,100 added to 8,100 is 16,200. And then our last step, you can't forget, I'm going to change colors so we can see it, is to take the square root of both sides. So my exponent and my square root cancel. And then I'm left with the square root of 16,200 is about, right, 127.3 feet. So I'm just using my calculator to figure out the square root of 16,200.